Today we are talking about solving logarithms and just understanding what logarithms are. Okay, students see log and you see words and it gets really strange. The key to logs, and this is the one thing you need to know, logarithms are the inverse of exponentials. Every single math teacher that I've ever been around has taught logarithms differently. Okay, you hear teachers talk about circle bend, and you talk about doing all that first, last, second. There's a bunch of different ways of saying it, but all of them are confusing. Okay, as smart as you guys are, if you remember that logarithms are the inverse of exponentials, you will think that this is so much easier than what you currently think. Okay, if I were to give you this math problem, 2 to the x is equal to 6, how would you solve it? You would divide by 2 because these two things being multiplied, we want to do the opposite of that. The opposite of multiplying is dividing. X is equal to 3. Right? And so is 2 to the x equal to 6 the same thing as 6 divided? I'm sorry, I'll come back to that. Let me come back to that idea. It's a good idea, but I'll come back to it in a second. Okay. And if I said x plus 3 equals 6, how would you get rid of the 3? You would subtract because that's the inverse. If I said x squared is equal to 4, what would you do to get rid of the square? Square root. You do all of those things because they're inverses of each other. Okay? That's the key. The reason we do the opposite is the inverse. It gets rid of it. The same thing is true with logarithms. If I have log base 2 of 8 is equal to x, make sure you can read that. Log base 2 of 8 is equal to x. That doesn't make a lot of sense to us. Okay? If I just asked you what's log base 2 of 8, you probably can't know that off the top of your head unless you just memorized it from before. But what we can do is the inverse of logarithms. The opposite of log base 2 is an exponential problem. So what we're going to do is we are going to raise both sides to have a base of 2. That's a weird thing to say, but I'm raising both sides so that both sides are now exponentials with a base of 2. All right, this and this are inverses of each other. So what happens when I take the square root of x and I square it? What happens to the square and square root? They cancel, and it leaves you with just x. So what's going to happen here, do you think, if I do 2 and log base 2? They cancel out. And so my problem now is just 8 is equal to 2 to the x power. 2 to what power gets me 8? 3. That is the answer. That is what log base 2 of 8 is. Okay, you can do it in your calculator if you don't believe me. But if I go, I forget, alpha F2? Yeah. Log base 2 of 8. Oh, yeah, it's 3, just like we just did without a calculator, because you don't need a calculator for that. All right, let's do the next one. Natural log of 1 is equal to x. Natural log. What is the inverse of natural log? What base is natural log? Do you know? It's e. That's why ln and e are on the same button. Natural log and e. Okay? They are inverses of each other. So if I put them together, what's going to happen when I do e and natural log of each other? They cancel, and they just get you whatever number you have. It's 1. So natural log of 1 is equal to x. I want to get rid of natural log, so I'm going to do the inverse, which is an exponential function. I'm going to raise both sides to a base of e. E and natural log are going to cancel. So I get 1 equals e to the x. E to what power is going to get me 1? 0. Okay? If we don't believe me, do it. Natural log of 1. Oh, the natural log of 1 is 0. That is a math fact you need to know. Natural log of 1 is 0. But we could do that by doing some simple change. Okay? What this is, log base 2 of 8. Okay? Log base 2 of 8 is equal to x. That is the same thing as saying 2 times 3 is equal to 6. And this thing right here being 6 divided by 3 is equal to 2. Are they the same math statements? No, not really. They're not exactly the same. But we just rewrote it in a different fashion. It's the same numbers doing the same thing, but they're written in a different way that makes it easier to understand. Okay? That's what we're trying to do here. The key to everything we do today is to change logarithms into exponentials because we don't like logs and exponentials aren't too bad. All right. So in this next section, all we are doing is changing each exponential to a logarithmic or vice versa. Okay. So we're just rewriting it the other way. So I get 4 is equal to log base 3 of 81. I want to change that. I don't like the word log, so I'm going to change it. What is the inverse of log base 3? 3 to a power. The base of 3 on both sides. It's a weird thing to say. I'm going to call on you later. And I said this first period, and still someone got frozen. It happens every time. It's okay. But I'm rewriting both sides to be a base of 3. So the 3 and the log base 3 are going to cancel. 3 to the 4th is equal to 81. I'm not doing any solving here. All I did was rewrite. That's like 2 times 3 is 6, or 6 divided by 3 is 2. That's a different statement, but it's still the same. Okay, that's letter A. Letter B. 5 to the negative 2 is equal to 1 over 25th. This is an exponential. We're going to write it as a logarithmic. So to write it as a logarithmic, we are going to do the opposite of 5 to a power. What is the opposite of 5 to a power? Log. And log with a base of what? Log base 5. So it's log base 5 of negative 2. I'm sorry, log base 5 of 5 to the negative 2 is equal to log base 5 of 1 over 25. I just took the log base 5 of both sides. Over here, what's going to happen with log base 5 and 5 to a power? They cross out. Negative 2 is equal to the log base 5 of 1 over 25. That doesn't really help us. Now we wrote it as a logarithm. Now it's more confusing than it was earlier. Okay, but that's what we were trying to do. We were just trying to go back and forth. Try C and D. On letter C, write that log as an exponential. And letter D, write that exponential as a log. Go. We've got log base A of 16 is equal to 3. Haley, how do I get rid of log base A?
You take, or I guess you put a base of A.
Good. A base of A on both sides. That's going to cancel. So she gets 16 is equal to A cubed because the opposite of log base A is A to a power. Okay, my next one, 2.4b, or to the b power is equal to 18.5. Eli, how am I going to get rid of it? What's the inverse of an exponential? A log. Good. So he's going to take the log of both sides. What log are you going to use here? Log of 2.4. Good. Because his base of his exponent was 2.4, so he took log base 2.4 on both sides. You don't have to write this all out. If that bothers you, don't do it. Okay, if you get the right answer, I don't care how you get there. If you remember something from back in the day, great. I just think it's better to understand that they're inverses of each other, and that's why we're doing what we're doing. Question so far? All right, let's keep rolling. Okay, we're evaluating the log. Log base 2 of 8. All right, if it just gives you log base 2 of 8, sometimes students get confused. Make it equal to x. Okay, give yourself another side because we're used to working on both sides. So just say it's equal to x. It'll help you understand it. So if I want to get rid of log base 2, what is the inverse of log base 2? 2 to a power. So I'm going to raise both sides as 2 to a power. I get 8 equals 2 to the x. 2 to what power gets me 8? 2 to the third. And so if you wrote it like that, now, the 2x is 3. Or you could just know that the answer to that question right there is 3. I don't care how you get there. But x is equal to 3. Try letter F. On letter F, log base 3, we get rid of log base 3. 3 to a power, 3 to a power. Boom. 1 over 27 is 3 to the x. So I know I've got a fraction. What has to be true about my exponent in an exponential to get me a fraction? It's got to be negative. And then 3 to what power gets me 27? It's 3. Okay, letter G, same thing. We set it equal to 0. I'm sorry, equal to x. We raise both sides to be a base of 9. 9 to what power is going to get me 1? 0. Anything to the 0 power is going to get me 1. That is a math fact you need to know. Try letter H. See what you get. We raise both sides to be a base of 2. The 2 and the log base 2 cancel. I get 2 to what power gets me negative 3? Show me your fingers. 2 to what power is going to get me negative 3? Nothing. No solution. Okay? Understand why. This is the inverse of exponentials. Think about what 2 to the x looks like on the graph. This is what we did on Friday. 2 to the x. Oh, it's this exponential function right there. When is that exponential function going to get me a negative number? Never. Nothing lives down here. Okay? We can't get negative. In fact, we can't get 0. Okay? We have a horizontal asymptote at 0. So what we learned by that is this thing right here. Okay? That thing after the log base, this is called the argument. Okay? The argument has to be greater than 0. Okay? That thing right there, the argument, has to be greater than 0 at all times because of that horizontal asymptote and it being above that line when we do exponentials. That's an important thing. Good on H. All of these are pretty much the same. I'll do one more here just so we can see it. But letter B, we raise both sides to a base of 2. Oh, I don't know why I skipped letter A. Whatever, I'm doing B already. I'm going to live with it. I raise both sides to a base of 2. That cancels. I get 3x plus 1. 2 to the 4th power. Oh, that's 16. And I just solve. X is 5. None of these are hard. You can do all of these pretty easily. Log base x, so I'd raise both sides to a base of x. 1 over 8 is equal to x cubed. What cubed is going to get me 1/8? What cubed is going to get me 1/8? That is 1/2. Because you know you need a 2 and it's got to be on bottom, so it's 1/2. We can go through and solve all those. Okay, couple more. We're almost done. We're going to skip C and D there. You guys can do them. I'm sure you're very capable. Log of x. Okay, log of x. There's no base here. It just says log of x. Anybody know what the base is when the number's not there? 10. Log base 10 is the most common thing. Okay, when you guys are talking about pH scales and AP Chem, okay, that is on a log scale. It's a base of 10. When you talk about the Richter scale with earthquakes, that's a base of 10. When you talk about decibel level, that's a base of 10. Those are the scientific things. That's what we're going to deal with. Okay, the number one thing that annoys me the most about iPhones is if you use the calculator on an iPhone and you turn it sideways, they put a 2 with the root sign. And that's super dumb. We don't need that 2. We know that if you put a square root sign, it is an implied 2. Same thing is true with logarithms. If they see a log, you'll never see log base 10 because if there's not a number there, it's assumed that it's the number 10. Okay, so no number. Okay, it's a base of 10. Natural log of x is the same thing as log with what base? It is a base of e. They won't do that. They just write natural log because natural log is a common thing. We do it all the time. So natural log is what we're going to use. Okay, so we saw this. What is the inverse? What is the opposite of log of just log? A base of 10. A base of 10 on both sides. The 10 and the log base 10 would cancel. And then I got 10 squared over there, which would get me 100. Okay, so you just got to understand that the inverse of that would be 10. Over here, if I've got natural log, what is the inverse of natural log? E. I'm going to do it E of both sides. So I get 2x is equal to e cubed. Divide by 2, divide by 2. I don't get a decimal. Just leave it like that. E cubed over 2 is a perfectly fine answer. Okay, you don't have to go decimal. We would never go decimal in calculus when we do that. Last thing, we're solving some logarithms. We can have an extraneous solution. Okay? Not only can the argument not be negative, okay, but something else also is going to apply. Solve 3 and 4 real quick with your neighbor and get an answer. Here we go. We're solving number 3. Jack, how'd you solve number 3? Good. Base of 10 on both sides. That cancels. 4x minus 8 is equal to 10 squared, so 100. Add 8. 4x equals 102. 8, 108, just playing. Divide by 4, divide by 4. X is equal to 27. Done. Last one. Monica, how'd you solve that one? Base of x, that cancels. 64 is equal to x squared. Then what? Square root both sides. So square root of 64 is 8 and negative 8, plus or minus 8, is equal to x. But both of those do not work here. The answer to this question is just the number 8. The base of a logarithm, that thing right there, has to be greater, it has to be positive, and it has to be not equal to 1. Okay, for a couple different reasons. Talk with your neighbor. It's a little bit weird, but why does the base of a logarithm have to be a positive number in order for it to be a function? Talk with your neighbor. Decide why that is.